fractional distillation. If in a mixture the difference in boiling point of two liquids is not appreciable, they cannot be separated from each other using the simple distillation assembly. To separate such liquid, the process is called fractional distillation is employed in which a special assembly is used. See figure 2.5a. In this assembly, the distillation flask is fitted with a fractionating column, figure 3.5b. Hence, the vapor first passes through the fractionating columns. Vapor of more volatile liquid with lower boiling point rise up more than the vapor of liquid having higher boiling point. Suppose we have a mixture of two liquid A and B having boiling point 363 Kelvin and 373 Kelvin respectively. A is more volatile and B is less volatile. As a mixture is heated, vapors of A along with a liquid of B rise up and come in contact with the large surface of the fractionating column. Vapor of B condenses rapidly into the distillation flask. While passing through the fractionating columns, there is an exchange between the ascending vapors and the descending liquid. The vapor of B are scrubbed off by the descending liquid. This makes the vapors richer in A. This process is repeated each time the vapor and liquid come in contact with the surface in the fractionating columns. Rising vapors become richer in A and escape through the fractionating columns and reach the condenser while the liquid in the distillation flask is richer in B. The separated components are further purified by repeating the process. Mixture of acetones boiling point 329 Kelvin and methyl alcohol boiling point is 3000 sorry boiling point is 337.7 Kelvin. Acetone and benzene 353 Kelvin can be separated by fractional distillations. This process is used in petroleum industry to separate different fractions of crude oils. 3.3.3 Distillation under reduced pressure. Liquids having very high boiling points or those which decompose on heating are purified by carrying out distillation under reduced pressure. In this method, the liquid is made to boil at a temperature which is below its normal boiling point by reducing the pressure of the surface of the liquid. Pressure is reduced using a water pump or a vacuum pump. In a soap, industrial glycerol is separated from soap by using this technique. 3.4 Solvent extraction. When an organic substance is present in an aqueous solution, it can be extracted from the solution by shaking it with an organic solvent in which the substance is more soluble. The organic liquid should be immiscible with water and be able to form two layers. In this process, the solute distributes itself between two immiscible liquids. From the aqueous phase, the solute gets extracted in the organic phase. Extractions of compound takes place based on difference in solubility of the compound in the two liquids. See figure 3.6. And shaking for a few times with small volume of organic phase. Most of the solute get extracted into organic phases. The organic solvent is then removed by distillation and the solute is collected. The solvent extraction process is important as it helps clean separation in a short time span. Solvent extraction, solvent layer, organic compound in aqueous layer, organic compound solvent layer, aqueous layer after extraction. If the solute is less soluble in organic phases, then a technique called continuous extraction is used, where the same amount of organic solvent is used repeatedly for extraction. This technique involves continuous distillation of the solvent within the same assembly. Thus, use of large quantity of organic solvent is avoided. Internet, my friend. Get more information about continuous extraction, SOX Health extraction from YouTube Royal Society of Chemistry, SOX Health extraction. Chromatography technique 3.5. Chromatographic technique. Chromatography is a technique used to separate component of a mixture and also verify compound. The name of the technique comes from the Greek words chroma meaning color. In 1903, Tesvet discovered this technique for separating the colored component found in plants. The principle of separation of substance in this technique is similar to solvent extraction, that is, distribution of the solute in two phases. In chromatography, we use two phases for separation, a stationary phase and b mobile phase. This technique is based on difference in rate at which component in the mixture move through the stationary phase under the influence of the mobile phase. First, the mixture of component is loaded at one end of the stationary phase, and then the mobile phase, which is a pure solvent or a mixture of solvent, is allowed to move over the stationary phase. Depending on the relative affinity of the component towards the stationary phase and the mobile phase, they remain on the surface of the stationary phase, moving along with the mobile phase and gradually get separated. The stationary phase can be a solid or a liquid depending on stationary phase. Chromatography is classified into adsorption chromatography and partition chromatography. Adsorption chromatography. This type of chromatography is based on the principle of differential adsorption. Different solutes are adsorbed to different extent on the stationary phase. Adsorption chromatography is of the following two types. Part 1, column chromatography. This type involves the separation of component over a column of stationary phase. The stationary phase material can be alumina silica gel, a slurry of the stationary phase materials filled in long glass tubes, provided with a stop cock at the bottom and a glass wool plug at the lower end. The mixture to be separated is dissolved in a small amount of appropriate solvent and is then loaded on the top of the adsorbent column. A suitable mobile phase, which would be single solvent or a mixture of solvent, is then poured over the adsorbent column. The mixture, along with the mobile phases, slowly move down the column. The solutes get adsorbed or stationary phase, and depending on the degree to which they are adsorbed, the solute gets separated from each other. The most strongly adsorbed component is retained on the column and others. Move down the collar to various distance forming band as seen in figure 3.7. The component which is less strongly adsorbed is dissolved first and leave the collar first, while the strongly adsorbed component is eluted later. Column chromatography, different stage of separation. Solvent, mixture of kappa A plus B plus C, adsorbent, stationary phase, glass wool. The solution of this component are collected separately. On evaporating the solvent, the solutes can be recovered. Point 2. Thin layer chromatography. A layer 0.2 mm thick of adsorbent silica gel or alumina spread across over a glass plate act as stationary phase. The plate is called the TLC plate or chroma plate. The mixture of solute is applied on the chroma plate as a small spot about 2 cm from one end of the plate as shown in figure 3.8. The plate is then placed in a closed jar containing the mobile phase such that the spot is well above the mobile phase. As the mobile phase rises up, the component of the mixture move along with it. They move up to different distance depending upon their degree of absorption and thus get separated. If the components are colored, they appear as separated color spots on the plate. If the components are not colored but have property of fluorescence, they can be visualized under UV lights. Or the plate can be kept in a chamber containing a few ionic crystals. The ionic vapor are absorbed by the components. Stage in thin layer chromatography jar adsorbent coated on a glass plate sample dot solvent baseline. Distal trial by solvent. Distal trial by the various dyes. Develop chromatogram. The spot appear brown. Amino acids are visualized by spraying the plate with a solution of lead hydrate. This is known as spraying agent. Partial chromatography. In this type of chromatography, the stationary phase and mobile phase both are liquid. Separation of component takes place by continuous differential partition of the component between the stationary and mobile phase. Example, paper chromatography. In this technique, a special quality paper, what matte paper number 1, is used. The water trapped in the fiber of the paper act as stationary phase. The solution of mixture is spotted on the strip of the chromatography paper at about 2 cm from one end of the paper. Using a glass capillary, the paper is then suspended in a chamber containing the mobile phase, taking care that the spot does not dip in the mobile phases. The mobile phase arise up to capillary actions and flow over the spot. Partitioning of the component takes place between stationary phase water and the mobile phase. Different solutes are retained differently on the paper depending on their selective partitioning between the two phases. This develop paper strips in the chromatograph, similar to TLC thin layer chromatography. The colored components are visible as colored. Spot and colorless components are observed under UV light or using a spraying agent. Retention factor RF. Vibration of the solute relative to the solvent part gives an idea about the relative retention of the solute on the stationary phase. This is termed as the RF of the solute. RF is equal to distance traveled by the solute from the baseline upon distance traveled by the solvent from the baseline. Solvent friend spot base retention factor. Internet by friend. Color chromatography. HTTP hyphen slash slash YouTube slash KQQIT XVFDLB8. Stages in paper chromatography.